today's Science Inquiry. I'm George Wolf, and today's inquiry is going to use a couple of tuning forks and hopefully your perceptive ear. Now, let's talk a little bit about what tuning forks are and how they work. They're kind of pieces of metal that are built to vibrate, and they have different pitches. For example, this one, when I hit it, gives a perfect C, and I can turn it off just by grabbing it, stopping the vibration. Similarly, this one, it's vibrating, I grab it, and it stops. So let's try that again. I'm going to hit it, I'm going to grab it, and it's going to stop. Now that's interesting. Let's see if that works the other way. Well, as you may have guessed, that's going to be a challenge in a few seconds. But first, I'm going to want you to look up a term, and that term is resonance. Now, after you look that up, I want you to try and answer this question that goes along with this inquiry, and the question is this: why did the second tuning fork vibrate when I hit the first one? Good luck with this one. When you answered that question, did you say that those tuning forks had the same resonant frequency? Or maybe you said they were identical in composition and would resonate with each other? Well, if you did, you got the right answer, and let's take a look at why. Remember I said in the beginning that this one is tuned to a C, if you will. That means it's vibrating at a certain frequency. And sure enough, if I turn it off, this one vibrates. Well, that one should make that one vibrate. Let's do that again. Watch what happens as I turn one off and the other one on. Turn this one off. Turn that one off. That's pretty cool stuff. So the real question is, if I were to change one of them, would that keep it from vibrating? So I had just this little metal piece on there. Now they're made out of different materials. Let's see what happens. You see, it's not vibrating. Let's go to the board and see why. All right, let's start out by talking about sound. Sound is caused by the vibration of the air. So in this case, what's happening is the tuning fork, when I stick it with my finger, vibrates back and forth. That is going to create vibrations in the air, the air is just going to move and go right into your ear. And I sure hope you guys don't look like that. All right, so your ears vibrate, and that's what causes sound. Without air, you don't get sound. Well, what about this whole idea of resonance? Well, here's what happens next. Say I have a tuning fork that is one material and one thickness, vibrating, and another one that I've hit vibrating. Well, let's look. Look at the difference between these vibrations and the gray vibrations. These are not going to affect this tuning fork, and these red ones are not going to affect the gray tuning fork. You get no resonance. That's what happened when I added the metal piece on, but when they are the same, we're going to get identical vibrations going that way and vibrations going that way. The two tuning forks will be able to affect each other. We call that resonance. Cool stuff. So let's summarize what we have here. Number one, you know that sound is caused by the vibration of air. Number two, different materials will vibrate at different rates. We call this their resonant frequencies. And number three, when two objects have the same resonant frequency, the vibration of one can cause a vibration in the other. That's neat. Hey, listen, you guys, I'm George Wolf, and I want you to remember to discuss today's science inquiry with your class and your teacher. And I'm going to challenge you again next time. But remember this, you'll never get any answers unless you ask those questions.